Students, can y'all hear me? It's 3 o'clock. Can everybody hear me? If y'all can hear me, right, I'd like you to type, hello, teacher. Okay, if y'all can hear me, please type, hello, teacher. I want to check. Yes, thank you, Jingxuan, right? Jingxuan. Oh, wow. Okay, awesome. Hi, Jenny. Hi, Benjamin. Ashton, Ian. Oh, okay, interesting name. How do you pronounce Mireille? How do you pronounce that? How to pronounce? Who is this? Can you like at least let me know how to pronounce your name? Don't worry, I won't call upon you later. Oh, Jessica. Hi, Jessica. Hello. Hi. Mireille. Okay, Mireille. Thank you very much. Okay. Thank you very much for attending my session here. Okay. All right. Okay. I'm going to share with you PowerPoint first, okay? Just to do a quick recap on the topic on angles, okay? I know angles, right, is actually part of your WA3, okay? For people who are, I think your WA3 for most of you should be in August, okay? Either the start of August or mid-August, okay? So angles will definitely be tested, okay? So we are going to look at some of the key concepts first before I go through the questions. Okay, I know some of you here, right? Either you skip your CCA or something to come and like watch my session. Okay, I really appreciate that. Okay, all right. Let's look at some of the important concepts first. Okay, if you all can see the screen here, right? Properties of angles. Okay, please type YAY, yay. Okay, please type yay if you can see my screen over here. Good, thank you. Okay, thank you, Ashton. Hey, Ashton, I think it sounds very familiar, Ashton. I think Ashton attended the MAP before. Sounds, yeah, familiar, Ashton. YAY, Benjamin. Okay, thank you, Benjamin. Okay, let's recap, okay? So, I know, okay, all of you know that all the angles, okay, on a straight line add up to 180, okay? Then all the angles that are about a point add up to 360, okay? And you know about vertically opposite angles. But, okay, a lot of you will miss out, okay, writing that, okay, this particular concept, okay, this particular angle property in your workings. Okay, I know that because when I check the work of my Sec 1 students, I realize they tend to leave the reasons out. Okay, these reasons are extremely important. Okay, this is the key difference between PSLE and Sec 1. Okay, a lot of you may be wondering, okay, hey, how come tested again? The same thing tested again in Sec 1. Okay, here we are not testing you exactly the same thing. Okay, here we are trying to test whether you know that, okay, you know all these angle properties. You know how to identify these angle properties and write them in your workings. Okay, this is the key difference between PSLE angles and Sec 1 angles. Understand? Okay, so everybody must memorize, okay, these reasons. Okay, we call them reasons, those enclosed in brackets. Okay, you see those enclosed in brackets, we call them reasons. Okay, so all these three angles ABC add up to 180. Okay, they fall on the same straight line. We call them adjacent angles on a straight line. Okay, adjacent meaning, okay, next to each other. Okay, next to each other. Okay, angles at a point, okay, we can write in short. Okay, so you see at the bottom, right, in the brackets, okay, angles we write in short. We use like this to mean angle. Okay, angles on a point or at a point. Okay, it means like all the angles congregate at a point, okay, and add up to 360. Okay, vertically opposite angles, okay, A equal to B, C equal to D, okay, they are vertically opposite. In short, right, you can write VERT dot OPP dot angles. Okay, VERT, by the way, in French, it means like green, okay, green, okay, in French, by the way. Okay, let's look at the next slide. Okay, then, okay, we have properties that involve parallel lines. Okay, so in this case, A, B, and CD are parallel lines. Okay, as a result of these parallel lines, right, some of the or rather, okay, some of these angles, okay, will be formed as a result of the parallel lines. In other words, okay, parallel lines must exist first, okay, in order for you to be able to spot alternate angles, corresponding angles, and interior angles, okay? What are alternate angles? So alternate angles are equal. So you see A equal to E, okay, B equal to D, okay? It is actually framed by the Z shape. Okay, I think it's not new to you, okay, the Z shape. Your teacher might have already told you, okay, Z, F, okay, etc. Okay, so alternate angles, right, they are identified or framed, okay, by the letter, capital letter Z. Okay, so you identify them by Z. Okay, another way, right, to identify would be to look at their positions relative to the transversal line. So you look at this line that cut across A, B, and C, D. Okay, the line that cut across, we call it the transversal line. Okay, so you notice something, okay, alternate angles, right? Okay, A, E, and BD, they fall on opposite sides of the transversal line. Okay, they do not fall on the same side. That means one is on the left of the transversal, the other one is on the right. Okay, on opposite sides of the transversal line. Okay, and then they have to be between the parallel lines. You realize both angles, right, are between the parallel lines. Okay, so this is another way to identify alternate angles. Hi, Desiree. Oh my God, Desiree, you're online. Yay. Desiree is my student. Yes. Yeah, she's here to support me. Thank you very much, Desiree. Okay, thank you. Okay, corresponding angles. Okay, corresponding angles, right? In short, okay, CORR. Okay, we don't have to write in full, by the way. Okay, in exams, time is of essence. Okay, we don't have time to, like, you know, state like everything in full like this. Okay, we don't have to spell out. Just write CORR dot angles. Okay, angles, you can use this sign to mean angle. Okay. So we also have to write down, right, which pair of parallel lines actually generate these angles. Okay, so in this case, AB parallel to CD. Okay, because they are parallel, that is how we can have these angles. Okay, these relationships. Okay, so it's important to state which parallel lines actually give rise to the following properties. Okay, okay, then corresponding angles, right? They are framed by the capital letter F. So we can use the capital letter F to identify corresponding angles. And they take the same relative positions. Okay, so for example, okay, A equal to C, D equal to F. Okay, A equal to C, D equal to F. You notice that, okay, they take the same relative position, okay, with respect to the parallel line. Okay, the same relative position. So that's why they are equal. Okay. Another way, of course, is to use the transversal line, okay, as a guide. So you look at the transversal line, right? Okay, corresponding angles will always be on the same side. In other words, either both are on the right or both on the left. Okay, so they are always on the same side of the transversal line, okay, and they both, okay, not both, only one of them, okay, only one of them will be between the parallel lines, not both, only one, okay. Interior angles. Okay, interior angles, right, add up to 180. Okay, they are not equal, by the way. Okay, they add up to 180. Okay, so sometimes we can say that they are supplementary. Okay, when angles add up to 180, we say they are supplementary. Okay, so yes, I'm going to go through polygons later also. Okay, this is a revision. Okay, a revision, or angles revision. Okay, all right. So interior angles, right, they are on the same side, okay, of the transversal and between the parallel lines. For example, A and B, D and E. Okay, okay, moving on. Polygons. Okay, let me go through certain key concepts. Okay, polygons are 2D figures, okay, with finite number of sides. Finite meaning, okay, countable. Okay, so if you keep increasing the number of sides, okay, as you increase, right, you realize that the polygon becomes more and more like a circle. Okay, so when it becomes a circle, it's no longer called a polygon. Okay, a polygon must have finite, that means countable number of sides. Okay, or you can say that it has to have straight sides. Okay, another way to remember is they have to have straight sides. Okay, straight sides. Okay, So the simplest polygon would be triangles. Okay, triangles has the fewest number of sides. Okay, so triangle. Okay, so these are how we name the triangles. Okay, sometimes we can name it by the angles. Okay, we can also name it by the sides. Okay, or we can yeah, usually it's like that. Okay, by the angles or by the sides. Okay. Okay. Moving on. Okay, all the three angles, okay, interior angles of a triangle add up to 180, okay? So we use the property angle sum of triangle. But do take note, okay? Certain schools do not allow students to use the symbol triangle, okay, this triangle, okay? So you have to follow whatever requirement, okay, of your school. Like if, let's say your teacher doesn't allow you to use this, okay, then you write out in full triangle, okay? A plus B equal to C, okay, because C is an exterior angle of this triangle, okay, we say that the property is called exterior angle of triangle, okay. So the exterior angle, right, is equal to the sum of interior opposite angles. C equal to A plus B. Okay, properties of quadrilaterals. Okay, most of the properties you are already quite familiar with, okay, except for maybe the diagonals part. Okay, diagonals are actually line segments, right, connecting the opposite corners, okay, of the figure. So for example, okay, in a rectangle you see here, okay, this slanted, okay, this tilted length, okay, we call it the diagonal, okay, connecting the opposite corners, okay. In a rectangle, the diagonals will bisect each other. Okay, the meaning of bisect, right? Bi means two. Okay, set means cut. Okay, it means like cut into two equal halves. That's the meaning of bisect. Okay, cut into two equal halves. So they bisect each other. That means they cut each other into two equal halves. Okay. In a square, okay, square is a special case of a rectangle, so it inherits most of the properties of a rectangle, characteristics of a rectangle. Okay, but on top of that, okay, there will be extra characteristics. Okay, so in a square, right, the diagonals not only cut each other into two equal halves, okay, the diagonals are also perpendicular to each other, okay, 90 degrees apart. So this is a very important characteristic that, you know, sometimes the setter, okay, of the paper, okay, of your school paper, okay, they actually expect you to know, okay, even they may not state it explicitly in the paper, okay, in the test paper itself, okay, but when by saying that it's a square, okay, and by including the diagonals, okay, so teachers actually expect that, you know, the students know that the diagonals bisect each other at 90 degrees, okay, and also bisect interior angles. In other words, okay, this diagonal will cut the 90 degrees, right, the interior angle into two equal halves, 45, 45, like this, okay? Okay, parallelogram, opposite sides are equal and parallel, okay, and also opposite angles are equal. Okay, this is something that a lot of, I noticed that my students tend to forget, okay, opposite angles are equal. Okay, that means okay, the two like diagonally, okay, they are actually equal, understand? Okay, but in a parallelogram, right, the diagonals bisect each other, but they do not bisect the interior angles. Okay, do take note. Okay, they will still cut each other into two equal halves, but all the four segments will not be exactly equal, okay, in length. Okay, for a rhombus, okay, rhombus behaves like a flattened square. Okay, behaves like a flattened square. So that is why, right, the diagonals also bisect at 90 degrees. Okay, just like in a square. Okay, because it takes on some of the characteristics of a square. Okay. Okay, you can actually find all these in your textbook, okay, or in the school notes, okay. So I'm just revising with you so that later on, right, when I go on to the questions, you will not be so lost. You will not be like, can't remember the angle properties, can't remember this, can't remember that, okay. Okay, in a kite, okay, a kite is identified by two pairs, okay, two pairs of equal adjacent sides, okay. To simply put, okay, you can see a kite as two isosceles triangles combined together. Okay, you can see it that way lah. Okay, like two isosceles triangle put together like this. Okay, so the longer diagonal, okay, a kite has two diagonals. Okay, one is the shorter one, the other one is the longer one. Okay, only the longer one, okay, will bisect the shorter diagonal. Bisect, that means cut the shorter diagonal into two halves. Okay, and also bisect the interior angles. Okay, only the longer one would do that. The shorter one will not. Okay, so always remember this. And the diagonals of a kite, right, they will bisect, they will intersect at 90 degrees. Okay, so that means they will meet at 90 degrees also. All right. Okay, trapezium easy. Okay, trapezium is identified by a pair of parallel lines. Usually, if the question gives you a trapezium, right, okay, all the angle properties you have to recall, okay, all the angle properties, right, that are related to a pair of parallel lines. Okay, usually, right, they will want to test like your concept of interior angles, your concept of corresponding angles, your concept of alternate angles. Okay, so usually when we see a trapezium, right, immediately, right, we have to recall the three concepts, the three important concepts, these three. Okay, I go back to this. Yeah, these three. Okay, the three important concepts, the three important properties. All right. Okay. Polygons. Triangle, three sides. Okay. Yeah, three sides we call it a triangle lah. Okay. Four sides we call it quadrilateral. Five, pentagon, hexagon, heptagon, octagon, nonagon, decagon, dodecagon. Okay. If you can wrap like this, okay, in the exams, then you have no problems dealing with polygons question. Okay. Remember the number of sides. Okay. I have a lot of students will confuse the hexagon and heptagon one, 6 and 7 sided figures. Yeah, they were confused. Okay, it will be like, oh, teacher, is a hexagon 7-sided or 6-sided? Okay, so this is a common, I would say it's a pitfall, it's a pitfall. Okay, common pitfall. Okay, so 6 and 7-sided. Okay, be careful. Okay, heptagon and hexagon, don't confuse the two. Okay, for the polygons, this whole section, right, you just have to remember two important formula. Okay, two important formula. The first one is that the sum of all the interior angles, right, okay, is taking the number of sides n. Okay, n can be any number of sides lah, depending on the number of sides of that polygon. Okay, sometimes it could be an unknown also. It really depends on the question. Okay, so n refers to the number of sides that the polygon has minus 2 times 180. Okay, for those who have attended my MAP, right, you should know why is it n minus 2. Any idea why is it n minus 2? People attended my MAP, anyone? I think Desiree attended. Desiree, right? Why is it n minus 2? Why is it n minus 2? Why cannot just n? Why cannot just n times 180? Why must I minus, or why must the formula be like n minus 2? Okay, I'm going to call upon people already. Desiree, why? Why is it n minus 2, Desiree? My dear Desiree? Charlie. Oh, I see Charlie. Charlie. Oh, I see Derek also. Charlie, why is it n minus 2, Charlie? Charlie, are you there, Charlie? Let me unmute. Unmute Charlie. Allowed to talk. Okay, Charlie, you there? Or y'all type? Can y'all type or not? I want to interact with everybody. Can y'all type? Tristan? Tristan, why n minus 2? Oh, somebody say, is it because the number of triangles formed within? Excellent. That's Benjamin. Yes, excellent. Very good. Well done. Yes, you're right. Yes. Okay. Because right, the polygon, right, okay, can be segmented into a few triangles. Okay, we can actually form a few triangles by connecting okay, the diagonals. Okay, so when you connect the diagonals, connect, right, then you'll be able to see just n minus 2, okay, number of triangles. Okay, I actually covered that in my regular lesson and also in MAP. Okay, so for those who have attended, right, you should be able to understand or should be able to answer this question. Okay, so n minus 2, number of triangles, you multiply by 180 because one triangle, right, okay, the sum of interior angles, okay, is 180. So you take the number of triangles that can be formed, multiply by 180. Okay, then you'll be able to get all the interior angles. Okay. Sum of the exterior angle 360. Okay, interior plus exterior, because they are angles on a straight line. Okay, so they add up to 180. Okay, so for example, this C plus X, B plus W, A plus V, okay, E plus Z, D plus Y. Okay, they fall on the same straight line, so add up to 180. Okay, regular. Regular means that all the angles and all the sides are equal. Okay, all the angles, all sides are equal, all interior angles are equal. Okay, and therefore to find one interior angle, right, you can take the sum of all the angles. Okay, so using the formula n minus 2 times 180. Okay, the sum of all the interior angles, you divide, okay, evenly by the number of angles n. Okay, so that's why we can apply this formula. This is only used if and only if, okay, the polygon is regular. Okay, that means it has all sides equal, all angles equal. Okay, if the question did not mention that it is a regular polygon, then you cannot just divide by n like that. Okay, cannot assume. All right. Okay, all the exterior angles add up to 360. So when we can, because okay, in this case, all the exterior angles are also equal. Okay, so we can just simply divide by n. Okay, just evenly distribute the 360. Okay, among n number of exterior angles. Okay, all right. Okay, this one is a geometrical construction. We will not be covering this part today. Okay. Okay, now I'm going to switch to my I'm going to switch to my iPad, okay? Okay, with all these in mind, okay, we are going to look at some of the questions. Have you already tried the questions? If you have tried the questions, please type yes. Okay, otherwise just keep quiet. Okay, otherwise you just type no. Okay, if you haven't no, okay, I see. Right, not yet. Okay, Ashton, no. Mireille, no. Jingxuan, right? Xuan or Xuan? Jingxuan, no. Also the rest done already. My dear Charlie done already. Charlie done already. Okay. Garrick done already. Haven't. Oh, Garrick, okay. Tristan, not yet. Seems like everybody not yet. Okay. All right. All right, since not yet, right? Okay, I'm just going to give you about 2 minutes, okay, to look at this question first, okay? Within the 2 minutes, right, I would like you to search for key information, okay? Search and obtain key information. Okay, so here we are going to use our solve, right? You know, we have this problem solving strategy, okay, called solve. Okay, a bit like yeah, but it's easy to remember. Okay, solve. Okay, so S and O, right, stands for search and obtain key info. Okay, so I'd like you to look at these or maybe just this question. Okay, just question number 1. I want you to search, okay, and obtain the key information. Very fast one. Okay, very fast, very easy one. Okay, that's about 1 minute. 1 minute. Okay. I'm going to set the timer. Okay, 1 minute. Okay, so you see I have this 58, 57, 56. Okay, counting down. Then later on it will ring. Okay. Oh, Tristan asked why must register. Don't need to register lah. Need to register. Really? No, you just write your name only, right? That's how you enter, right? You just write your name. Yeah. Oh, Asher is here also. Asher, do you skip your CCA, Asher? Don't tell me you skip your CCA, Asher. Yes. Oh, you skip your CCA. Oh, how supportive. How supportive. Oh, by the way, I'm not encouraging everyone to do the same thing, but he's really very supportive. Oh, time is up. Okay, see, time is up. Okay. Okay, search and obtain key information. Okay, so when we look at this, okay, when we look at this diagram, okay, it's actually quite, it's not like a question with a storyline or anything. Okay, so it's quite direct, okay, what they want you to find, right? Okay, so first, okay, the first important key point is that AB is parallel to DE. Okay, that's an important key point. Okay, because with that, right, there are three important angle properties that we will have to relate. Okay, why you raise hand? Asher raised hand. Why? Yes, Asher, is there a question? Yeah. Okay, so these three are these two lines are parallel. Okay, these two lines are parallel. Search and obtain key information, key info. Yeah. Okay, key information. Yeah. Okay. Okay, so AB parallel to DE. Okay, AB parallel to DE. Okay, so with that, right, okay, we will have to recall the three important angle properties related to parallel lines. Okay, so we have, this will come after, this will come under, sorry, this will come under this. Okay, list all methods. Okay, all right. So we could use alternate angles. Okay, we could use alternate angles. Okay, or we could use corresponding angles or interior angles. Okay, because the fact that, you know, there are a pair of there's a pair of parallel lines, and then with that, okay, there are three related angle properties. Okay, that is why we can pick one of them to use. Okay, it really depends on, you can use, actually we are quite open, okay, to all possible solutions. Okay, provided, okay, you can actually write your workings in a logical and coherent manner. Okay, so, and then support, okay, with proper reasons meaning angle properties enclosed in brackets. Okay, so long as you can support it properly, okay, we will give the mark. All right. Okay, so in this case, right, you see that A, B, and DE, right, they are not directly related. Okay, because the parallel lines are quite far apart. Okay, not directly related. In this case, we can actually create, okay, we can actually draw our own additional lines. Okay, who's that? Who's that? Obtuse angles are angles that are bigger than 90 but less than 180. Oh, okay. Okay, okay, so we can draw additional lines, right, that cut at C, okay, and parallel to AB and DE. Okay, so sometimes when we approach angles question, okay, we can create our own additional lines. Don't be restricted. Okay, provided, okay, you provided you draw, okay, if the answer space is together with the question paper, okay, provided you draw it clearly on the diagram. Okay, if it is separate, for example, if you have to hand in a separate piece of a foolscap paper, then in that case you will have to copy your diagram, okay, to the foolscap paper, and then you draw the additional line there. Okay, you can actually create your own additional lines. Okay, so I'm going to draw additional lines, okay, like this. So I'm going to draw here. Okay, not to scale, not to scale, by the way. Okay, like this. Okay, so I've created my own additional line, okay, that actually cuts at C, and this line, right, parallel to A, B, and DE. Okay, so after I've added this additional line, right, it becomes very clear already. Okay, how I can go about finding the x. Okay, all right. So we are going to resolve, okay, on a suitable method to solve this question. Okay, we want to find x. Our info is right here, here, and here. Right, our info are there, okay, right there, okay, where the numbers are. So in order to find x, right, okay, we can actually find these two angles. Say I let this be A, this be B. Okay, if I know what A and B are, then I can use 180, okay, minus A minus B. Okay, they are adjacent angles on the same on the straight line. Okay, so they should add up to 180 degrees. Okay, A plus X plus B must add up to 180. Okay, so if I know what A and B are, okay, then I can take 180 subtract A, subtract B. Okay, how do you go about finding A given 137? Okay, given this 137, right, how can we go about finding A? Who knows? Okay, I'm going to Brian. Yes, thank you very much, Brian. 180 minus 137. What's this angle property called? What's this angle property called? So Brian has chosen interior angles. Yeah, sum of interior, very good, very good. Okay, good job. Interior angles, okay. So Brian has chosen interior angles. Okay, so this method to actually solve the question. Okay, very good. Okay, so he has already resolved on a suitable method. Okay, so he has chosen this method, okay, that he's most comfortable with. Okay, so next, okay, after we have chosen the method, right, we are going to execute the plan. Okay. So angle A, okay, is 180 minus 137. Okay, very good. Well done. Okay, 180 minus 137. So this, right, okay, this is called interior angles. Okay, we can actually name the additional line that we drew. Okay, we can call this EF, for example. You know, E is already used. Okay, we can use FG. Okay, we can use FG. All right, so we can say, right, how these interior angles, how do we come up with these interior angles? Okay, they actually come from the parallel lines FG and AB. Okay, well done, very good. Okay, now next, how do you find B then? How to find B? Can we use the same method to find B? Yes or no? This B here, this B. Is it possible to use the same method to find B? Or is there another way that you want to use to find B? Asha? Asha Kwan? Asha, are you there, Asha? Wow, why so quiet suddenly? Everybody's so quiet. Nobody knows how to find B. Really? To find B, right, actually there are a few ways you can approach the question. Okay, you can either do this. Okay, I'm going to draw this. I'm going to extend this line ED. Okay, so there are a few ways. Okay, we can actually extend this line ED, right? Okay, and then we find this angle here that I just colored in yellow, this angle. Okay, we can use this angle. Okay, how do we use this? We take 231, okay, 231 degrees, subtract 180. Okay, subtract this 180 over here. Okay, then we can use this angle. And then this angle here is equal to B. Okay, because they are alternate angles. This angle in yellow, okay, is actually equal to B because they are alternate angles. Okay, this is one way. Okay, this one way, alternate angles. Okay, another way might be very good, my dear Charlie. Okay, my dear Charlie, yay. Okay, Charlie, very good. Okay, yes. So Charlie says that we can take 360 minus 231. Yes, awesome, very good. Okay, so another possible way, right? Okay, is to take angles at a point. That means you take 360, okay, minus 231 to get this angle here. Okay, CDE. So after we have found this CDE, right, we use the same way. We use interior angles. Okay, we know that interior angles add up to 180. So we can take 180 minus this angle CDE to give us B. Yes, we can do that as well. Okay, so I'm going to just follow the method that Charlie suggested. Okay, so I'm going to find angle CDE, 360 minus 231. Very good, good job. Okay, so angles at a point. Okay, they are angles at a point because they add up to 360 and they congregate at a point. Okay, it's at a point, right? It's at a point here. Okay, at point D. Okay, so that's why it's called angles at a point. Okay, then after that, we use the method that Benjamin, okay, and Brian suggest. Okay, so we are going to take 180. Okay, angle B will be 180, subtract 129. Okay, 51. Okay, interior angles again. So FG parallel to AB. Okay, and then finally to find X, right, we just take 180 minus A minus B. Okay. Adjacent angles on a straight line. Okay, can? Okay. If you are done, right? Okay, done with this. Okay, I'm going to generate a word. Okay, actually at that time during MAP, right, I played this game, okay? So I used a website, okay, that has a word generator. Okay, so I randomly generate a word. And then if you're paying attention, you're supposed to type that word. Okay, but I find that if I do it here, right, then I keep having to switch the screen. Okay, I scared some of you cannot catch like the workings and all that. Okay, so it's fine. Okay, so if you're done, right, please type. Wait, let me see what's the word to type. Type flowers. Okay, type flowers. Okay, if you're done with this question, type flowers, please. Thank you. Thank you. 花朵. Oh, Benjamin is so cute. So funny. Okay, 花朵. Okay, I see. 花朵. Okay. How about the rest? The rest are not done yet. Can y'all like, once y'all are done, please type flowers, okay? Yes? Somebody raise his hand. Somebody raise hand. Wait, who's that? How come somebody raise hand? Who's that? Who's that? I'm trying to find out. Yan Shi. Is that Yan Shi? Somebody raised hand. Who's that? I can't find. Yeah, I can't find the person already. Yep. Okay, but I knew somebody raised hand. Yep. But I can't find the person suddenly. Yan Shi or something. Yeah, I think her name is Yan Shi. Yeah, but she disappeared suddenly. Right. Okay. Good. Okay. Now I'm going to go on to the next question already. Okay, I'm going to go on to the next question. Oops. Okay, we look at this question. Okay, question number 2. Question number 2 is a very tricky question. Okay, it seems easy, but it is not. Okay, question number 2 is a lot of people, okay, will just directly give the answer 45. Okay, you look at question number 2. Refer to the figure above. Okay, line PQ and SR. Okay, so PQ SR over here, right? They say that PQSR cut by the transversals AD and BA. Okay, so cut by these two transversals. These two. Okay, cut by these two lines. Find QEA. So to find QEA, right, this angle here, okay, given the other three angles, okay, so have been labeled for you already in the diagram, okay, this angle, this angle, this angle, given. So we have to find QEA, okay, but I know a lot of people, right, a lot of students will just say, oh, QEA is 45, so easy, then they just write down 45, finish, okay. Okay, this is a common mistake, okay. In this question, like I mentioned, okay, in order to use the fact that, or not the fact, like in order to say that QEA is 45, okay, you have to use the angle RHE, this one, this angle H over here, right? So the relationship, so you're actually indirectly, okay, implicitly saying that, okay, the two angles, angle H and angle E, okay, they are equal because they are corresponding angles, okay? So implicitly, you're trying to say that. That's why you concluded that QEA is 45, okay? So, but the question now is that, okay, there's no mention of any parallel lines in the question, okay? Nobody says that PQ is parallel to SR, okay? There's no mention about parallel lines in this question, okay? So in this case, right, we will have to use converse theorems, okay, to prove that the two lines PQ and SR are parallel first, okay, before you can even use the corresponding angles property, okay? So we have to conclude that PQ and SR are parallel first, okay? So this is how we are going to plan, okay? So we have already searched and obtained the key info, okay? So we are going to do some planning now, okay? I'm going to do some planning now. So this is like our strategy, okay? So we're going to strategize. So we have to show that PQ, okay? We need to show that PQ and SR are parallel first, okay? Before we can conclude that QEA is equal to RHE, okay, or GHE, okay, or GHE. Okay, so before that, we have to show that they are parallel first, okay, before we can even use the corresponding angle property, okay. But how do we show? Okay, usually to show a pair of parallel lines, we use converse, okay, either converse of, we can choose one of these, okay, converse of alternate angles, okay, corresponding angles, or interior angles. Okay, so we need to go one step back and then see, right, okay, oh, which of these we can actually use over here. Okay, so we look at the two other numbers given, okay, 101 and 79. Okay, 101 and 79, right, they have a very special relationship. Okay, they add up to 180 degrees. Okay, a very special relationship. Okay, and this is called interior angles. Okay, they are interior angles. Yeah, okay, they are interior angles. All right, so this is a special relationship that we can actually use to help us prove that the two lines PQ and SR are parallel. Okay, so we can actually look back, okay, and then see like what other numbers we can actually use to help us. Okay, so before this, we need to write down first, okay, plus 79 actually gave us 180. Okay, and by converse of interior angles, okay, by converse of interior angles, we prove that PQ and SR are parallel. Okay, here. Then from here, right, we can conclude that QEA is 45. They are corresponding angles and they use the fact that PQ and SR are parallel. Okay, so when we present our workings, right, we cannot do assumptions like, you know, like right away. Okay, we cannot just like if it's not given in the question, we cannot just assume PQ must be parallel to SR or assume something is 90 degrees. Okay, that's a very common mistake. Students like to assume something is 90 degrees when they see like it looks like 90 degrees, then they just assume it's 90. Okay, so we can't do that. Okay, so we have to always look back at the question, right, and see what is given. If the question right that the angle is 90, then we can take that as 90. Okay. Okay. If you are done, okay, please type. Done with this question, please type angles. Okay, everybody type angles if you are done. Angles. Angles if you are paying attention. Okay, if you are paying attention, type angles. I want to count the number of people. How many didn't type? I want to see, okay, how many didn't type? I should have quite a number of people here, you know. By right, I should have like 24 people here. I should have 24 angles here. How many angles do I have now? 2, 4, 6, 8, 10. Less than half. By right, I should have 24 angles here. Desiree, where's your angles? Desiree? Is Desiree there? Charlie? Tristan? Asher? Garrick? Has Garrick typed? Garrick has done it. Okay. Great. Okay, let's move on, okay? Let's go on to the next question. Question number 3. Okay, ABCD is a square. Okay, so we are going to first search for key information. Okay, the 5 steps that 4 steps, okay, that I've listed just now. Okay, solve, right? Our solving strategy, solve. So the first step is to search and obtain key information. Okay, so we are going to find key information first. ABCD is a square. AGFD is a parallelogram. Okay, so with that, right, you have to recall all the characteristics, okay, angle properties, or rather angle properties, okay, of a square and a parallelogram. Okay, so in a parallelogram, right, opposite angles are equal. So in other words, okay, this equal. Okay, this equal. Okay, then for a square, right, oh yeah, and also another thing is, okay, for a parallelogram, opposite sides are parallel. Okay, opposite sides are parallel like this. Okay. Okay, for a square, okay, the diagonals will bisect, okay, the interior angles. Okay, and also the opposite sides are parallel in a square as well. Okay, so in a square, right, each angle is 90. Okay, so we have to note down all these. Okay, so each angle is 90. Maybe I use another color, this one. Okay, each angle is 90, 90, 90, 90. Okay, then the diagonal, BD is actually diagonal. Okay, diagonal will bisect the interior angle. Okay, in a square. Okay, the lines BD, GC, and CE are parallel lines. Okay, all right. Okay, given already. Okay, AG and BC meet at H. Given that GFD is 66. Okay, so they are trying to tell you, right, that this angle here, this is 66. Name 2 angles that are equal to GFD. Okay, we have to find 2 angles that are equal to GFD. Okay, that means 66. 2 other angles that are 66 degrees. Okay, so I mentioned just now, right? Okay, in a parallelogram, okay, opposite angles are equal. So this is one angle in the parallelogram AGFD. Okay, so the other angle that is equal to this 66 degrees has to be the opposite angle. Okay, so the angle that is directly opposite, which is GAD. Okay, GAD. GAD. Okay, maybe I write down there. Okay, here. Okay, GAD is also 66. Okay, because it is an opposite angle of the parallelogram. Okay, we can use this to mean parallel. Okay, parallelogram. All right. Okay, next. Okay, we need one more angle, right? What is the other angle? Any idea? Name me one more angle that is equal to 66 as well. Who is this very bright, very smart person who can answer me? Who is this super intelligent person who can answer me? What is this other angle that is also equal to this 66 degrees? Asha? Is Asha there? Still there? Okay, I'm going to ask Asha top. Okay, how about Benjamin? Benjamin, what do you think? What's this other angle that is also equal to 66? What's this other angle that's also equal to 66? DAG. DAG. Benjamin says DAG. DAG, I just mentioned it. GAD, DAG is the same. It's the same thing, okay? DAG and GAD, the same thing. Okay, I've just mentioned already. Okay, any other angles also equal to 66? GHC. BHA, okay, wait. GHC, very good. Well done. Charlie says this angle, GHC, this one that I just highlighted in red, this is also equal to 66. Well done. Okay, very good. Okay, you notice that these two, right, they are equal, okay? GAD and GHC because they are corresponding angles. They take the same relative positions, okay? And they actually come from the parallel lines HC and AD. Opposite sides of a square, right, are parallel. How come? I shouldn't use this. Maybe I use this. Yeah. Okay. So opposite sides of a square, okay, are parallel. So AD parallel to BC, okay, and therefore we can use corresponding angles like this. BHA, yes, very good. Well done. Okay, I have another answer from Lei Ping, right? Is that Lei Ping? Okay, this one. Okay, BHA, very good. Okay, BHA is also 66. Okay, alternate angles. Very good. Okay, so y'all can come up with a lot of answers. Well done. Good job. Okay. Oh, you use your mom's name. Then what is your name? I don't know your name. If you don't write down your name, what's your name? Can you tell me your name? Shane. Okay, Shane. I see. Okay, no wonder. Okay, I'm like, how come? Oh yeah, okay, Shane. All right, thank you. Okay, next we look at AHC, right? AHC. Just now we have somebody identified, I think Shane, right? Shane identified that BHA is 66. Okay, so AHC, right? We can use adjacent angles on the straight line. Okay, because AHC is over here. Okay, I use another color. Here. Okay, this one, AHC. Okay, so angle AHC and BHA, they lie on the same straight line. Okay, so they form 180. So we can take 180, subtract 66. 114. Straight line. Okay, part C. CED. CED. This angle here. Let me highlight in pink. Okay, this angle over here. Okay, so to find this angle over here. Okay, can? Okay, now next, okay, to find this angle over here, right? We can actually use this, okay, we can use CED this plus, we can use exterior angle of a triangle. Okay, we can actually use this one. Let me use this color in pink to show you. Okay, we can use this. I'm teaching you the shortest way to get to the answer. Okay, of course there are many ways. I have students who tell me, oh, if I don't want to use this, I want to use a very long way, can I do so? Yes. Okay, like I mentioned, okay, there are many ways to solve a problem. Okay, and we are very open to all different perspectives. Okay, but of course, if let's say there's an even more efficient method, okay, to get to the answer, okay, I will lead you to that. Okay, I will lead you to that method. Okay, so to find CED, right, okay, we already have the 66 given to us. Okay, 66 already given to us. So actually, right, the shortest way to do this question is if we are able to find EGF, this one, this EGF over here, okay, then we can just take 66 plus this EGF, and that will give us CED, exterior angle of a triangle. Okay, because it is the exterior angle. Wait, let me highlight this for you. Okay, so the exterior angle of this triangle GF. Okay, so if we want to find this EGF, right, you can actually go downwards, okay, to look at this angle here. Okay, I'm going to highlight in pink this angle, HBD. Okay, HBD. HBD and EGF, okay, they are actually equal because they are corresponding angles. They take the same relative position with respect to the parallel lines BD and GE. Okay, they take the same relative positions. So from here, right, you see it is between the line, okay, this angle, right, is between the line BC and BD. When we look at the other angle here, EGF, it is also between this line GF, which is parallel to BC, okay, and GE, which is parallel to BD. So we can say that these two angles, right, they are equal, okay? They take the same relative position with respect to the parallel lines, okay? So therefore, this angle, right, EGF, it has to be equal to 45 degrees as well. But before we use that, we have to first write down, right? Let me write down first. Okay, we have to first write down angle CBD is 45. Okay, how do we know that? Because, okay, the diagonal of a square, okay, it bisects the interior angle. Okay, it bisects the interior angle. It bisects the 90 degrees. It cuts 90 degrees into two parts. So we know that this is 45. Okay, so from here, right, we can find angle FGE. This is also 45, corresponding. Okay, corresponding angles. GF parallel to BC, GE parallel to BD. Okay, so they are corresponding angles. So from there, right, okay, once you know this already, you can find angle CED by adding the two, 66 and 45. Exterior angle of a triangle. Okay, answer. This is the shortest way to find the answer. Okay, but of course there are many other ways. Okay, if you are creative, you can come up with different ways. Okay, but this is actually the shortest way, which I find that I want to let you know so that you can actually use it in your exams. Okay. Exterior angle, right, can save a lot of time if you know how to use that property. Okay, so some of you, right, I know a lot of students would like to find this angle first, angle CEF first. Then after that, you take 180 minus CEF and then find CED. You don't need that. Okay, that is a little too long-winded. Okay. All right. Okay, moving on. I'm going to speed up a bit already, because I know some of you got I know some of my students are in school. So I need to speed up a bit. I don't know whether you are in school or not, but I heard like some of you have your CCA or something, so you are like somewhere else. Yeah. Okay, so I'm trying to like not take up too much time. Okay, let's look at question number 4. Okay, question number 4. Okay, a kite. Okay, a kite. Related properties. Okay, the diagonals are 90 degrees apart. AC, BD are diagonals. Okay, so when you look at kite, right, you need to recall the related properties. Okay, diagonals are 90 degrees, are perpendicular. Okay, or you can say it's perpendicular, right? 90 degrees. So this is 90 degrees. All right. Another related characteristic, right, is that the longer diagonal, okay, only the longer diagonal, okay, bisect the interior angles. Okay, so in other words, this equal to this equal to this. Okay, then there's one more. Okay, I've also mentioned, right, that the adjacent sides are equal in length. In other words, okay, a kite is actually made up of two isosceles triangles put together. Okay, so the adjacent sides must be equal. AB equal to BC, AD equal to CD. So with all these in mind, right, usually the question will not state all the characteristics. So you are supposed to recall and know all these characteristics beforehand. Okay, so when we see a kite, right, all the characteristics should come naturally. Okay, so everything should be linked, like it should come naturally like that. Okay, so you need to study the characteristics well enough. Okay, so now we have to find ABX. Okay, ABX, this angle here. Okay, maybe I highlight in another color. Okay, I use blue. Okay, ABX, this one. Okay. Okay, so to find this angle, right, you can actually find the angle CBX first, because CBX is equal to ABX. Okay, so you can find CBX first. Okay, so to do that, you just take 180 minus 90 minus 53, right? Okay, but before that, it's not so simple, not so direct, okay? Our workings are quite, yeah, okay, you have to state all the properties involved. Okay, I know it's a little cumbersome. Okay, some students say, yeah, very a lot of things to write, but yes, okay, you have to. Okay, so we have to state every property clearly. Okay, so because, right, we cannot just assume, we have to state, okay, CXB, we know this is 90. And how do we know that? Because, okay, diagonals of a kite are perpendicular. Okay, so this is the related property. Okay, so after we have stated that this is 90 degrees, we can go on, okay, and say that, oh, so now CBX is 180 minus 90 minus 53, okay, which is 37, okay, because we use angle sum of triangle. Okay, we use this property. Okay, so this 37 CBX, okay, is equal to ABX. This is also equal to 37. Okay, but how do we know that? Because the longer diagonal bisect the interior angle. Okay, BD bisects angle ABC. Okay, so we have to state very clearly all the related concepts. We cannot miss out a single reason. Okay, so long as you have touched that concept, you have to state. And we cannot combine concepts together. That means you cannot like in one step, right? You write multiple reasons at the side. Cannot. Okay, have to be separated. You cannot write multiple at the side. Okay. BAD. Okay, BAD, this angle. BAD in black. To find BAD, right? Actually, quite simple this question. Okay, because ABD is a triangle. Okay, interior angles of triangle add up to 180. So we take 180 minus away part A. Okay, we have in part A, this is 37, and then minus 28. Okay, and that will give us the remaining the angle BAD. Okay, like 1 hour is like a little short to go through 5 questions. Or is it because I talk too much? Is it because I repeated too much at the start? Okay, must be I talk too much at the start. Okay, if you are following, okay, please write please write question 5. Okay, please write Q5 if you are following. Write Q5. Yes, Shane is following. Yes. 问题5 第5题 not 问题5 Q5 yes. Okay, good. Okay, let's go on to question number 5. Okay, 第5题 yes, Q5. Okay, good. Okay, let's go on. Okay, question number 5. Okay, the diagram shows 2 regular pentagons. Okay, pentagons, okay, 5-sided. Okay, so we have to recap, okay, related concept. Okay, so we search for important clues. Remember at the start, search and obtain important information. Okay, key info. So pentagon 5-sided. Okay, so it's important. All right, then we have to find x, right? So x is over here. X is the interior angle, one angle only, okay, of the regular pentagon. Oh, why is it like that? Okay, regular. Okay, regular meaning, right, all the angles, all the sides are equal. This is also one key info, okay, that we cannot forget, like that. Okay. So all the sides, all the angles are equal. So to find one interior angle, right, we just need to use the formula. Okay, so we recap the formula. Okay, this question has no other ways to solve besides to use this lah. Okay, this is the only method. Okay, no other ways already. Okay, besides to use the formula. Okay, so the formula, right, for sum of interior angles. Let's recap. Okay, of a polygon, of n-sided polygon. Okay, it would be n minus 2 times 180. Okay, so in this case, right? Yes, very good. No, times 3, not times 5, n minus 2. Asha is n minus 2. Yes, n minus 2, not times 5, times 3. Okay, yes, forgot to minus. Yes. Okay, so part A part 1. Okay, A part 1. Okay, so x, right? X is actually one interior angle. Okay, one interior angle of the pentagon. Okay, regular pentagon. So to find, we use the formula to find the total interior angles first. Okay, so 5 minus 2 times 180, because there are 5 sides. Okay, so n is 5. Okay, then you divide by 5 angles. There are 5 angles in total. And because they are all equal, so we can just divide by 5. Okay, evenly distribute. So we can just divide by 5 like this. Okay, answer is 108. Ta-da, finish. Okay. Okay, part 2. These two are identical pentagons. Okay, identical pentagons. So the interior angles, right, are the same. So we have already found out that x is 108. That means the other one has to be 108 as well. Okay, because they are equal. Okay, equal. All right, so to find y, okay, to find y, we can just take angles at a point. Why you forgotten to minus? Okay, yeah, correct. Brian, very good. Good job. Yes. Okay, 360 minus 2 times of 108. Okay, so to find y, okay, we take 360, okay, minus 2 times of 108. Okay, 2 times of 108. 144. And this is called angles at a point. Okay, we need to state because we are taking the fact that all the angles that are at a point add up to 360. So we have to write down clearly, okay, the concept used. Okay. Okay, part B. Additional pentagons of the same size. Okay, so that means they are going to add, okay, more of the same thing, okay, more of the same pentagons, okay, to these 2 pentagons. So we are going to add more, okay, to form a closed ring around this regular polygon over here, the one that I just highlighted in blue. Okay, do take note, this is an open polygon. Okay, this is open. This is not the whole thing. Okay, this is not the complete shape. Okay, there are more sides. It's just that here we can't draw everything. Okay, we just like draw part of it. Okay, usually it will like that. It will appear like this in the exam. Okay, they will just show you an open polygon. That means it's not like a complete one. Okay, and then they ask you to guess the number of sides. Okay, so that will happen. Okay, so what is the least number of pentagons required to form the ring? You realize something, one pentagon, right, correspond to one side. Okay, one pentagon actually like it stick to one side. It corresponds to one side. So if you know, right, the number of sides, then you can find the number of pentagons. Okay, so in this case, right, the key here is to find the number of sides. It's just indirectly telling you to find the number of sides. Okay, so we have to find number of sides for this open polygon here. We know that the interior angle is 144. Okay, there are a few ways. Okay, we know that this is 144 lah. Okay, we know the interior given. Okay, this is given. So we search and obtain key info. This is given. Okay, the interior angle is 144. There are a few ways, okay, to find the number of sides. Okay, first method, okay, method number 1, you can use this times 180, you divide by n. Okay, since we know that this is a regular polygon, okay, so we can just divide by n. Okay, and this you equate to 144. You use the interior angle to solve. Another way, which I think, okay, it could be an easier way, okay, for most of you, because I know some of you, when you see algebra, you start to panic. Okay, you start to like, oh, why is it like that? Okay, how to solve for n, right? Okay, so there's another simpler way. Okay, a simpler way is to use the exterior angle. Okay, is to use the exterior angle. Okay, interior plus exterior add up to 180. Okay, so you see here, this angle here, angle A here, is actually the exterior angle of the open polygon. Okay, so we know that because they add up to 180, okay, we can find the exterior angle. We can find each exterior angle. And then since all the exterior angles add up to 360, okay, you just take 360, divide by one exterior angle, you can find the number of sides. Okay, so this is another easier way, which I think when I mark my students, I realized that they have been used, a lot of them like to use this lah. Okay, find the exterior angle first and then divide. Okay, yeah, okay, I think that is easier for most students. Okay, so you can find the exterior angle first. So for example, this one, okay, I will write like that. Okay, exterior angle is 180 minus 144. Okay, and this gives me 36, right? Okay, so I write down, okay, adjacent angles on a straight line, okay, because together, interior plus exterior must be equal to 180, okay? So after that, okay, I'm going to take 360, Okay, the sum of all the exterior angles, regardless of the number of sides. Okay, the sum. Okay, so pentagons, the total, right, is 360. You divide by each exterior angle, and that will give you the answer. Okay, so actually, right, the exterior one is easier to deal with, because if you do the first method, you will have to solve the equation. Okay, you will have to solve the equation for n. So we will have to expand also. Okay, so 180n minus 360 equals to 144n, so on and so forth. Okay, so I think a lot of students will not like this lah. Okay, will not actually like this. Okay, all right. Okay, 5 questions already. Okay, so if you all have learned something, okay, if you have learned something from this session, please type what? Please type I love webinar. Oh no, just type webinar. Okay, just type no, just type love, 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 or like. Okay, like or love. Okay, if you have learned something from this webinar, like, yes, thank you very much, thank you Shane, thank you Benjamin, thank you Ian, Yan Shi, yes, thank you Charlie webinar. Charlie is still okay. Okay, thank you Charlie, thank you for coming. Okay, Charlie. Yes, Asher, why you hide? Why, what happened? What do you want to say? No, were you listening or not? I said that, okay, if you learn something from the webinar, please type love or like. Okay, because you can't press like here, ma. So you have to write like. Yes, okay, thank you. Okay, thank you everybody. Okay, so if you have any questions, right, okay, or anything that you want to ask, I know your WA is coming up and angles is one of the topics. Okay, so you can always reach me by this email. Okay, I give you my email address. Okay, this one. Okay, Nicolle at BlueTree Education. Okay, .com. Okay, so this. Okay, then you can take a picture of the question, okay, and then send it to this email.